Waves. You see them literally everywhere. In the ocean, in the sunlight, even in the sound of my voice reaching your ears. They're such a core part of our reality, but they hide a really surprising secret, a paradox that kind of messes with your intuition. So let's dive in and get to the bottom of it.
Okay, picture this, July 9th, 1958, a remote place called Lituya Bay in Alaska. In one single violent moment, a wave of almost unimaginable power completely reshaped the land. On the left, that's the bay before, and on the right, that's after. Just look at that tree line. The wave was so huge, it literally scoured the trees clean off the mountainsides, hundreds of meters above sea level.
So how huge are we talking? That wave reached a staggering height of 530 meters. That's 1,740 feet. To put that in perspective, at the time, it was taller than the tallest building on the entire planet. All of that destructive power, all carried by one single wave.
So, what on earth could cause something like this? Well, it started with a magnitude 7.9 earthquake. That quake triggered a massive landslide. About 90 million tons of rock and ice came crashing down into this narrow inlet, creating the largest wave in recorded history.
And this, right here, brings us to the central puzzle. We all learned that waves don't actually move stuff forward. Think of a buoy out in the ocean or a rubber duck in your bathtub. It just bobs up and down as the wave passes underneath it. The water itself isn't traveling from one side of the ocean to the other. So, if the water isn't moving, how could it possibly unleash enough force to strip an entire forest from a mountainside? That's the question we're going to unravel.
The answer, it turns out, lies in a really fundamental principle of physics. It's all about understanding what a wave truly is.
At its very core, an ocean wave is a type of mechanical wave. And the two most important words in that definition are transfers energy. A wave is really just a disturbance, a vibration that moves energy from one spot to another through a substance, which scientists call the medium.
So, the best way to think about it is that waves are couriers for energy, not transporters of matter. The energy is what's traveling through the water, but the water molecules themselves, they're pretty much left in the same place they started. A few simple analogies really make this click. We've got the buoy just bobbing up and down. Then there's the wave at a sports stadium. People just stand up and sit down, right? They don't actually run around the stadium. It's the wave that moves, not the people. But my favorite has to be a line of dominoes. The first domino doesn't fly to the end of the line. No, it just transfers its energy to the next one, and so on. That traveling transfer of energy, that is the wave.
Okay, so how does this energy transfer actually work? I mean, what's going on under the hood? To understand that, we need to take a quick look at the anatomy of a wave.
First, it's really important to know there are two main families. You've got mechanical waves, like our ocean waves or sound waves. They absolutely need a medium, some stuff to travel through. But then you have electromagnetic waves, like light or radio waves. They're totally different. They're just vibrations of electric and magnetic fields, and they're perfectly happy traveling through the empty vacuum of space. It's how we can see stars that are millions of light years away.
And all waves, whether they're from the ocean or a distant star, they all speak the same language. Amplitude is the wave's height, and this is key. It's directly tied to how much energy that wave is carrying. Wavelength is just the distance from one peak to the next, and frequency is how many of those waves pass by a certain point every second.
So what is really going on with the water particles under the surface? Well, they're not just bobbing up and down. This is the cool part. They're actually moving in tiny circles, these little orbits. They go up, forward, down, and back, ending up almost exactly where they started. It's the energy from this circular motion that gets passed along, creating the wave we see. And back in Lituya Bay, it was this exact energy, just scaled up to an insane degree, that carried enough force to rip trees right off a mountain.
So, there you have it. Waves move energy, not matter. Case closed, right? Well, not exactly. Physics loves a good plot twist.
This quote kind of gives the game away. The distinction between mass and matter might seem small, but trust me, it's where things get really, really interesting. You might be wondering what Einstein's most famous equation is doing here, but it's actually the key to the whole thing. What it tells us is that energy and mass are basically two sides of the same coin. In a way, energy has mass. So, this leads us to a pretty mind-bending question. If a wave is transferring all this energy, and energy itself has mass, does that mean a wave is also transferring a tiny, tiny amount of mass?
And the answer is yes, it absolutely does. A wave transfers the mass that's associated with its own energy. But, and this is the crucial part, it does not transfer the mass of the medium it's traveling through. So the water molecules in Lituya Bay stayed in Lituya Bay, but the energy of that wave, which has a tiny bit of mass equivalent, did travel forward. It's a subtle difference, but it's a profound one.
And the weirdness doesn't even stop there. If you look at a group of waves, the individual little peaks can actually travel at a different speed than the group's overall energy. It's like new waves can pop up at the back of a ripple, race through the group, and then just disappear at the front. It's another one of those mind-bending examples that shows how the movement of energy is a totally different thing from the movement of the wave's physical shape. So, this is all fascinating physics, for sure. But why does it matter in the real world? Well, it matters because we've learned how to harness this incredible energy transfer in some amazing ways.
We've absolutely learned to harness these principles. Think about wave power generators. They don't work by scooping up water. They work by capturing the energy from that little orbital motion of the water particles to create clean electricity. Or take polarized sunglasses. They work by blocking light waves that are aligned in a specific direction, which proves that light, an electromagnetic wave, has physical properties we can actually manipulate.
So you see, whether we're talking about the raw, destructive power that reshaped Lituya Bay, or a potential source of sustainable energy from the ocean, or the light from distant stars carrying information across the cosmos, it's all powered by the exact same principle. This incredible transfer of energy. It's what makes waves one of the most fundamental forces in our entire universe.
So yeah, the buoy just bobs. The crowd just stands up and sits down. But the energy moves on. A wave is almost like a ghost. It's a pattern of energy passing through, leaving the world behind it almost untouched, except, of course, for when it doesn't. It really makes you wonder what other profound physical secrets are playing out all around us, just hiding in plain sight.